Hello world and good day everyone. My name is Gani Alaleka and I'll be taking the course on data modeling in machine learning. Now without further ado, I'll quickly start by introducing the topic and discussing on the steps involved in modeling data in machine learning. Then I would kind of address the audience in which the course is meant for. First, what is data modeling in machine learning? Data modeling in machine learning is the process of creating machine learning models capable of predicting labels from futures, tuning them for the business need, and validating it on old out data. What this means is that data modeling is a series of processes, and this series of processes is intended to first extract the target column from the data set now, where the target column refers to what our outcome or what we aim to predict is, and then we try to create a model that finds the relationship between the rest of the future columns in the data set to this column, where the majority of the future columns, which could range from 1 to n, represents x, which is our data, and y represents the target, which is what we are aiming to predict. Now, the processes involved in actually making this happen is what we call modeling, modeling creating a model rather for the task. Now, the output from the data modeling process is a trained model that can be used for making predictions on new data points. And this is the concept of generalization, where we are sure our model isn't just fixed to a particular system, but is now able to learn on new instances. Now, why do we model data in machine learning? The objective of machine learning is that it aims to create models that mimics the understanding of real-world situations through data and apply that understandings on real-world scenarios. Now, we model data to act as a bridge because in most business settings, the objective of people are to actually like infer the data from what they've learned, from real-world instances, and then deduce what is to come. Now, we want to be able to create models that can actually do these things. So the models will actually act as the um, we are the model machine learning engineers now. We act as the middleware where we try to create a bridge between the data now, which in the previous slide we discussed to be the x and the y. We try to create that bridge between the training data and what the outcome should be. So we model data to basically create this bridge, what we would also call a pipeline that actually understands what the relationship between the variable x and the y is. Now, there are various processes or steps in modeling data. This includes the preparation of the data, shortlisting of promising models, fine-tuning the system, creating a pipeline for the model, and finally presenting the solution. But before we jump into these steps, let's quickly talk about the tool that we'll be making use of. Now, the major tool we'll be making use of is the scikit-learn tool, which is a Python package that houses a series of machine learning algorithms alongside other useful algorithms to perform machine learning functions. And what this implies is that um, scikit-learn is a package or a library of algorithms, and the intent of these algorithms is to um, make the intent of these algorithms is to manage machine learning tasks, which could start from pre-processing the data, making um, predictive models, and the likes. Now, why scikit-learn? Aside from the fact that scikit-learn is simple and an effective tool for predictive data analysis, it is also open source, that is, it is accessible to everyone, and it is reusable in various contexts as well. It is also built on NumPy, SciPy, and Matplotlib, which are major tools that you could call fundamental in the terms of data science and machine learning. So we move straight to the very first steps in preparing the data. The first step would be the data cleaning. And data cleaning just has to do with the removal or the fixing of outliers that exist in the data set, as well as imputing missing values from the data. Now, if you've worked with a data set, one of the most common things you see is in your data set, they are not always complete, in the sense that, let's say in a particular future columns of a data set of, let's say, a rule of 400 now, there might be a future column that contains missing values of up to 100 now. If you were to drop these all columns, you will reduce the size of the data set. So you need to find methods to fill this this thing, this missing data points, or you could just go ahead and remove them. So this process of filling the missing data points or removing it is what we call the data cleaning processes. Then the next step in data preparation is future selection. Now, this is not always common, but in some cases it might be necessary. What future selection just has to deal with is the removal of irrelevant future columns from the data set. But before you actually deal with the removal of irrelevant future columns, you have to kind of have studied your data set to know which future column is more relevant than others. So future selection just has to deal with this process of removing irrelevant future columns from the data set. The next is future engineering, and this is a very, very essential step in data modeling, because it actually could determine how well your model will perform based on how well you engineer the various features now in the data set. And there are various steps in engineering the features. That is, decretize the continuous column, decompose. You could also decompose features. You could add promising transformations on the features, like using the log of the future, the square of it, yeah, and just the different methods for engineering the futures. Then another mode is by scaling the futures. That is another mode of preparing the data now. That's to do with scaling the futures. This has to do with like applying standardization on a particular continuous future column, or normalization on those future columns. Now, after you've gone through these rigorous steps of preparing the data, which actually takes a while, especially when you are working with a very new data set where everything is, in its raw form, scattered, and the rest. Because one of the other was intriguing this thing of data cleaning is all the data will not necessarily come out in the format that you require it to be. Some numeric data could actually contain values like hash or the hyphen and the like. So you have to clean all of those out. But once you are done with the cleaning of the data, preparing it, scaling, future engineering, and the like, the next thing you do is you shortlist promising models for the data. And you do this by um, picking up and picking out data models that you feel should work properly on this. So the first way to do this is to first know your problem. What kind of problem are you working with? Is it a regression problem? Is it a classification problem? Once you've clarified that out, what the next thing you do is you pick out the kind of models rather that best solve these problems. Then after you do that, you do a quick training. That is, train each and every one of them to see which one actually performs well. Just that quick um, check of the performance of each model at their default with their default parameters. You measure and compare their performance. You analyze the most significant variable for each algorithm. You analyze the type of error that the model makes. Then you perform a quick round of future selection and engineering. That's if you haven't before. Like as I said, the future selection is optional, but when you start training on the model, you might actually start realizing some things now while you are trying to select a model, that okay, this particular feature does affect each models this way and the rest. So you could perform quick form of feature selections and engineering on it. You could perform one or more quick iterations on the listing on the model, and at least just select the models that you feel perform best, which could be a single model, two or three models from the series of models that you selected. Now, I wrote a little article that I will attach at the end of this video on the steps involved in selecting a model, because it's harder to explain. One of the best way to get this stuff is having it in practice, either by watching how it is done or by seeing how it has been done. So I wrote an article that actually addressed the problem of shortlisting promising models. So you should do well to check that out. So after you've selected the series of models that you feel are necessary or would suit the problem better, the next thing you try to do is you fine-tune the hyperparameters of that model by using cross-validation processes. Now, this is an extensive period, kind of like when you were doing the data cleaning process. But the reason why this is more complicated is that for most of the time, you won't actually be doing anything. It's kind of like you will just be switching the parameters and be saying, okay, what parameter or what type of parameter now makes this model actually perform well or makes the model bloom and all of those kind of stuff. So you try different assemble methods. That is by combining maybe after shortlisting model, you can try combining two or more model that in a process called um, voting classifiers or voting regressors. You try to combine your models and see if they perform well. Now you keep doing all of these iterative processes until you're able to get a single model or multiple models that when combined actually performed optimally, and you are confident about this. Once you've been able to fine-tune a particular model, you head on to creating a pipeline. Now, the process of creating a pipeline actually starts before um, before the data cleaning process or during the data cleaning process. Um, you know that you have to perform a series of data analysis now on your data set to see what changes need to be made. When you are encoding the listing, the encoding of categorical feature columns, the scaling of continuous feature columns, and whether they should be scaled or not, and all of this stuff. Then the pipeline is nothing but the incorporation of all that you've been doing from the start all the way to the fine tuning of the system. So basically, a pipeline is nothing but a system that holds the processes of actually cleaning the data set, imputing values into the missing um, future columns that might be provided, that will be provided in the data set, and for the new data set, it does the function of cleaning it, filling in missing value, performing transformation, that is encoding the data set, especially the categorical feature columns, and preparing everything for the model and then fitting it into the model. So after fine-tuning the model, it is essential to create the pipeline that handles all the processes of cleaning, selecting features, and engineering the features as well. Ultimately, the purpose of a pipeline is to allow you to increase the iteration cycle without the added confidence that simplifying the process gives, and to scale how many models you can realistically maintain in production. Now, at the end of this, you'll be presenting your solution, which would be the case of now finalize what you've done and be able to make use of it in production. So, in conclusion, I believe the concept of data modeling in machine learning has been properly resolved. I actually believe that it has been resolved. What we'll be doing is we'll also look into why we model data. Um, we talked about the steps now necessary in modeling data for machine learning, but these steps were actually taken from the book on hands-on machine learning with scikit-learn, keras, and TensorFlow, which was written by Aurélien Guillon. I really don't know if I got his name right, but um, most of these steps that we made use of were gotten from that book, and I will actually recommend the book for those that are interested in going deeper. That is aside from the data modeling steps in machine learning. And now the concept of addressing the audience. The work that I did with the DSN community from UNILORIN was based for the beginners. Actually was beginner level, but I try to integrate the course in such a way that I can actually skill those that are actually just coming into the field and those that are not so new into the field. And that I did this by actually not just providing the videos, but beautiful lecture notes that um, can help people to quickly grasp the concepts that I explained here quicker. And we'll start with the first video, which has to do with modeling um, data for regression taxes. So thank you guys for starting out this, and I hope you actually learn a lot.